Hello everyone, in this little video I will try to show you how to thread cut a metric thread on a Colchester Chipmaster lathe with an Imperial setup. So the lathe screw is Imperial and then the gearbox is Imperial and everything on it. There's nothing metric on this lathe. So what I will going to do is show you the basics on how to basically cut a metric thread. So before cutting any thread, what you want to do is plan ahead. In this case, this is my cunning plan, and believe me, this is a lot better than what the customer supplied me. So basically we are going to cut an M10 by 1.5 pitch thread to the 6G standard, and we have a piece of bar which is already has the business end, this end done, which is a brooch. You can see it here. I'm going to chuck this up here. I'm going to rough it out to thread size, and then we are going to cut the thread. First and foremost is you want to have the right tooling. So you need a tooling holder for a threading insert. The right insert, I mean, you need to have the right pitch. So this is a 1.5, as you can see, ERB 1.5 ISO. So that's a brand new edge there. I'm gonna lock it. So this one thing is out of the way. I know I have a screw cutting tool with the right insert in it. I've got a roughing tool here and I got a finishing tool here. Before we can cut the right thread, we have to set the gear train to the right pitch, or to the right setup, because we can set the pitch from the gearbox, but we will get to that one as well. But I think for the most of you are confused about the gears. So what we have to do is to set it up to cut metric threads according to the table which is located there in the back of the gear cover. At the moment it's set up to Imperial threads, and this one, middle one, this is a conversion gear which has a 65 and a 55 tooth. So basically this does the conversion from Imperial to metric. So what I have to do is, as you can see, this gear runs on this gear, so basically this just acts as a middle gear or a idling gear, and then it turns this one. What I have to do is this will run the 55 and the 65 will run this big one, and then we can cut metric threads. That's the all the magic in this, and there's nothing else you have to do other than this. So my gear setup is a little bit botched. I will kick it into low gear so it will stop moving, and I will remove this, and I will remove one of the gears and I will put it to safety, and then I just used this collar here and a bunch of spacers to make up the missing gear to put this nut back on. Then I'm gonna loosen this, I think it's called a gear banjo, and this gear here, which can slide up and down on the gear, on the banjo. There you go. And now, as you can see here, this will go behind to the 55 tooth gear, and I'm going to lock it down there. And then when I undo this one, I can move the banjo so this will create contact again with this one. When I move them together, I don't push them all the way together, or at least I do, but then I back off a little bit so it has a little bit of play. That will be fine. So now we have it set up for metric threading, and I'm going to show you them the conversion gear. So this is the conversion gear. This is one solid piece, but in this side it has 55 tooth, and on this side it has 65. So basically this will drive this through the conversion gear and through the gearbox, into the gearbox. So now that I have my gear set up, I will close the cabinet, and I haven't roughed out the bolts OD yet, but we're gonna set up the, obviously for in low gear, the gearbox. This one, because I'm gonna cut from right to left, so this will be here and not here. That makes sense. And obviously this going to be in the threads position, not on the feeds position. So I'm gonna thread cut and not feed. The 1.5 millimeter pitch resides at B4. So if this one is in A, you set it to B, and this lever you put it to 4, number 4. There. You engage the lead screw, and you're ready to start cutting threads. So here I have the future bolt here. The other end is machined, and we will rough out the screw OD, or the screw thread OD. I have the roughing tool put up, and I'm gonna rough it out from this face to whatever I need. I think it's 25 mil depth to a size of, because we need a 10 mil, so I'm gonna rough it out to 10.1. And the reason is because it's not 10 or not 9.8 or whatever, is because we are using a screw cutting insert, which is a full profile, and for these inserts you have to leave a little bit of meat on the roughed out OD so they can finish it off. So this doesn't mean that the screw will be bigger, it will be the right size, 9.87 I think, or about there, but we will leave the excess material for the screw cutting insert to finish it off. So this is now roughed out to the, hopefully to the right size. I will take a measurement. Should be 398. It's 415, so we can take another pass. I think this should be now roughed out to 10.1, which is 400. 10.3. I think I will leave it as it is. Here is the screw cutting insert. What I do is, my compound is set to 45 degrees, and I'm gonna leave it as it is. This finisher likes to lurk around. I'm gonna set this to 0, and I'm gonna monitor it that it will stay at 0. I'm not gonna touch this, I'm not gonna bother with it. I'm only gonna use my cross slide. This is square to the axes. The insert is square to the job. I know for sure because every time I set this tool post up, this is square to the axes. So I'm gonna bump the tip of the insert against the OD with the cross slide. And here I'm gonna zero it just for fun. Usually I just remember the number that is there if it doesn't coincide with the what I wanted to have, but just for the purpose of this video, for fun, I'm gonna zero it. So that is at 0. And I'm gonna engage all the mambo jumbo in the gearbox and the gear train and whatever I need, and I am going to run like a just like an empty pass, and I'm going to show you how to do that. So as you can see, my spindle is turning, all my gears are set up, my tooling is set up. I'm ready to cut that witness pass or that chucking pass. You can see my thread cutting indicator turns around and is ready to be engaged with the lever. I engage this dog here, screw cutting dog, and what I will do is I will engage this one and I will leave it on. I won't touch it anymore until the thread is done. So let's try that now. It's at number 3. I'm going to engage it. Engaged. We're moving. When I reach the end, I will stop the spindle, but I will stop the motor. And I'm going to reverse it. Now I'm not going to disengage this nut. It will go back. The spindle will start reversing and the tool will retract. And I will stop there where I feel it. So this was just a demo to show you what is going to happen. I'm gonna put my phone back on a stand and I'm gonna do it for real now. Here it goes. When I reach my certain depth, I will wind out the cross slide, just a half turn, reverse the motor direction, and I will come back to my starting point. Come out, reverse. That's it. This is the very first pass. So before I do anything, I will take a thread gauge and check for the right pitch. That pretty much matches perfectly. So this proves that I've set up the right pitch in the gearbox, in the gear train. So when I cut my real cut, my very first real cut, I will go in 10 thou. The next I will go 5 thou, then maybe another 5, maybe cut a spring pass. You will have to experience yourself and with what material you're cutting and what grade of insert you're cutting, what shape of insert. So very first pass, here we go. Put some oil on it. That's the very first pass, 10 thou. Reverse it up. I like to have it lubed all the time, but for the sake of this video I'm gonna try to put as less possible. So I'm gonna lube it up now and then leave it off. So as you can see, I'm just reversing the motor direction back and forth, and the cross slide, that's it, nothing else. I'm not engaging or disengaging the screw cutting lever. I'm just going to back out with the cross slide now, reverse the motor, take the next pass. It's a bit time consuming to go back and forth. It should be easier to cut imperial threads, and being able to disengage and just then quickly engage again at the right position. But for metric threads, this is what you have to do. Obviously you have to be very careful not to hit the face of your chuck or the job So you gotta be prepared to either reverse the motor or quickly engage the clutch so it doesn't go anywhere. I have the VFD set up, so I'm just going to press the backwards reverse button, which quickly reverses the direction of the spindle. So this is very convenient for me for thread cutting. And the thread, as you can see, looks really rough. It looks really rough until you get to a certain depth, and the profile of the insert will start cutting. If I put oil on it, as you can see, the oil will wash off any chips instantaneously as they are being produced. So this is why I like to have the oil on constantly, but just for the sake of the video I won't put it on all the time. And also I can wash off the tip of the insert and have it nice and clean all the time. Deeper and deeper you go, the bigger chunks it will take out. So after a good few passes, that rough finish on the thread will go away. So that means the full profile of the insert is going into that roughed out OD. And at the moment it is 10 mil exactly. So I should be going in a couple more thou to reach 9.9, 9.85. This is what I'm aiming for this standard. I don't know if you can see it, but the insert is cutting on both sides and on the profile edge as well. So that means that this thread is really smooth. As you can see, I can put my finger on it without cutting myself. So it's so smooth and nice. It's really amazing. I'm gonna take a measurement again. That is now 9.9. So I'm gonna take a spring pass. I'm gonna leave the oil on now. What I should have done is use the micrometer because it's easier to show you. It's basically 9.80, almost 5. 9.83 and a half. So we are pretty much right in the middle, from 73 to 96. So this is a perfect thread. We can also measure the pitch diameter with the pitch micrometer, but for this thread and this spec I think it should be alright. The next thing you can do is just try it with a nut. It should run perfectly on. The thread is so nice and fine. My camera doesn't really pick up on this, but it's really superb. Thanks for watching. Hope you learned something from this video. Have a good time. Thread cutting. Bye.